Hi folks, we're going to take a look at this half-life problem. So they tell us that a substance decays from 20 to 15 grams in 7 hours, and they want us to use that to find the half-life of the substance. Okay, so first thing is to remember what a half-life model looks like. So if A is the amount of material, okay, and that's going to be equal to the initial amount, okay, and we work with time periods for which the substance decays to half of its previous value. So that's why we use 1/2 as our base. Okay, T will be the amount of time that elapses. But say in this case here, T is in hours. It doesn't necessarily decay by 1/2 every hour. So we have to divide by the number of hours that it takes to decay to 1/2. So we'll use H for half-life. So here we'll say T is in hours, okay, and we'll say H is the half-life, also in hours. Okay, so this is what we have to solve. We have to solve for H. So let's see the information that we're given. So we're given an initial and final value for a particular experiment. So we know that if we start with 20 grams, so A naught is 20, it's going to decay to 15 grams, all right, and that's going to take 7 hours. And we realize that the only information that's left to find is that half-life, which is exactly what I'm looking for. Okay, so now at this point, it's just about solving this exponential equation. So let's go ahead and do that. So again, we can't use logarithms at this point. I guess we could. If we took log of both sides, then we could use the first logarithm law to separate it out because we have a multiplication. But it's much easier to just divide out the 20 to both sides. Okay, so 15 over 20 is 3/4. So that's going to be 0.75 equals 1/2 to the 7 over H. Okay, now since I know that I'm looking for an approximation here, since there's a context to this question, instead of taking log base 1/2 of both sides, I'll just take log base 10 of both sides. Okay, so we have log of 0.75. Okay, here we've done a few of these problems, so I know that when I take the log of the right-hand side, I can also apply the ski slope rule to that logarithm. So I'm going to do that right off the bat. So this is going to give us 7 over H times log of 1/2. Okay, because this would have been log of 1/2 to the 7 over H. So just save myself a bit of time. So at this point here, I just have to solve for H. So I'll multiply H to the other side, and I'll divide log base 0.5 to the right-hand side. So I end up with 7 log of 1/2, 0.5 over log of 0.75. And there we have it. Now again, because we wouldn't normally give a half-life in this format, we'll find an approximation. Okay, if I was looking for the exact answer, this would be an exact answer. So let's get our calculator here. And we've got 7 times log of 0.5. And let's divide that by log of 0.75. Okay, and we've got, looks like 16.9 hours. So approximately 16.9 hours. Okay, now let's just take a quick look to see if it makes sense. It took 7 hours to go from 20 to 15. Okay, so not quite half of the original amount. So it makes sense that our answer is going to be more than 7 hours. So if I had gotten an answer that was less than 7 hours, that wouldn't have made sense. Okay, so let's just recap what we did. Number one was to remember what a half-life model looks like. So base 1/2, and whatever our time value is, we divide it by however long it takes to achieve getting to half of the previous amount. Okay, and then from there, when I was solving my exponential equation, I needed to make sure that I got to a single exponential expression equal to some number before I took logarithm of both sides. Okay, that's it for this one.